Chapter 2.7, Misleading Graphs and Stats, or Statistics. So for your vocab today, I want you to look up the word misleading. Now, misleading is not in your book. You're going to need to use a dictionary, but I really want you to understand what the term misleading means. So the purpose of misleading graphs and stats is to be able to look at graphs and tables and ask yourself a couple of important questions. First, is my graph that I'm looking at accurate? Because if the graph isn't accurate, or if the information isn't shown accurately, it can skew what you think about it, or it can change what you think about it because the information isn't necessarily correct. The second question is it meant to influence you? Is the graph meant to make you think a certain way about the information? Does it want you to think that there was a big jump or think that there was a small decrease? Is it meant to influence you, or is it meant to just give you the information and let you make your own decisions? So let's take a look at example 1. This graph shows the mayor's performance over 4 months. The question says, each month residents of a town were asked, do you think the mayor is doing a good job? The results are shown. Which statement tells why the graph may be misleading? Now I'm going to tell you first of all that this graph is definitely misleading. So here we have our months, January, February, March, April. Doesn't seem anything wrong with that. Each month is consecutive, January, February, March, April. They're spaced evenly apart. I have my label of months. Okay, so that seems okay. But let's take a look at our y-axis. Percent who approve. So down here I start at 0%, 5, 10, 15, 20. So I'm counting by fives. But then all of a sudden, if you look here, I jump to count increase by 20, and then I have another jump where I increase by 30. So my decrease between January and February is actually minus 30%. But because most of my graph is counting by fives, it looks like I only have a decrease of 5%. But then here in between February and March, I have a decrease of 20% because I'm going from 40% down to 20%. And yet it looks the same as going from 70 to 40, which was a 30% decrease. So this is a multiple choice. And if you're looking at your book, the answer is C. The vertical scale uses uneven intervals. Whenever you make a graph, your intervals, meaning the distance between each place, has to be the same. If I'm adding 5 at the beginning, I have to add 5 all the way up. I can't skip and suddenly add 20 and then add 30. All right, example number 2, car sales. An auto dealer made a graph at the right showing how many cars were sold. So here, April, May, June, 3 months. It looks like between April and May I had a pretty big jump, and between May and June I had a huge jump in car sales. If I just looked at the bars, I'd be like, whoo, look, big jump, really big jump. However, if we take a look, my graph does not start at 0. It starts at 76. So the difference between April and May is actually only 2 cars, and between May and June is really only 3 cars. Well, 3 cars out of about 80 cars really doesn't make that big of a difference. So why does the impression, or what impression does this graph give? it looks like A, it gives the impression there was a big increase in sales. Okay? Because it looks like there's a lot of space, but when you look at the intervals and the fact that it didn't start at 0, 3 cars really isn't that much when you're looking at 80. So why is the graph misleading? The graph is misleading which you all know the definition of because you looked it up, because the y-axis doesn't start at 0. Let's go make this a capital T. It is a complete sentence. Okay? The graph is misleading because the y-axis doesn't start at 0. So therefore, it looks like there's a big difference. But if you were to have these graphs continue down all the way to start at 0, these would be really long tables, and they would not actually look like there's that big of a difference between them if we made these nice and long all the way down to 0. So, example 3, identifying misleading statistics. 5 players on a professional basketball team have a mean salary of $2.2 million. $2.2 million, or $2,200,000. Same thing, okay? It's a pretty big average. Their 5 salaries are shown here in the table. Explain why the mean may not be the best measure for describing the players' salaries. So if I look at these salaries, I have 800,000, 800,000, 1 million, 1.2 million, and 7.2 million. Well, there's only one number that is greater than my mean, and that's that 7.2 million. These 4, these are all relatively close together. But this baby up here, there's your outlier. So, the mean is not a good measure to describe the data because there is only one larger data point. It is much larger than the others. So is an outlier. Okay? Just for fun, or quick check 3 is going to ask you which would be better, the mean, the median, or the mode. Okay, that's it for examples. Please do your quick checks in your CYU, and we will go over this the next time I see you.